Good morning. So let's continue with reviewing. And on question number 2, I'm going to review a little bit about motion. Of course, if you already forget a lot, you can go back to watch the video before that about the motions. So let's take a look at number 2. So from the interval 0 to 12 inclusive, a particle moves along the x-axis. The velocity of the particle at time t is given by velocity v of t equal cosine pi divided by 6 times time. The particle is at the position x equal -2 and t equal to 0. So we know the initial position x of 0 equal to -2. Let me write a little bit better. X of 0 equal to -2. That means P of 0 equal to -2. So it means the same thing. So now we had to use the letter X instead of P. Part A, for this time interval, when is the particle moving to the left? So we say that when the velocity is negative, the particle is moving to the left. When the velocity is positive, the particle is moving to the right. So we are going to use the calculator to graph it because you're allowed to graph. You're allowed to use calculator on your AP exam. So now I type in the cosine pi divided by 6 times x, and then I made my window 0 to 12, and I'll set my y min and my y max from -2 to 2 because this function, the biggest value is 1, so the smallest value is -1. So now we're going to graph it and see where. So this is the graph of the velocity function. Okay, so I'm going to copy it over here so you can see it better. 0 to 12. So this 2 point, at this point over here, the particle stops. At this point over here, the particle also stops. So now let's find out the exact location. So it looks like it's at the 3 and the 9. If you can see it, so you can directly write it. If you cannot see it, so you can use the 0 button. So now on your AP exam, so you may not be able to see it so clearly, so you have to do it. So it is 9 because you count backward. Okay, so 9, and then you're going to find the other one. So I found the other 0 first, and then go back to find the first 0. Okay, so now the other one is 3. So this is below the x-axis, so therefore on the interval 3 to 9, we do not include 3, we do not include 9. V of t is negative. Okay, so the particle is moving to the left on the interval 3 to 9. So now let's review a little bit. This was not asked in the question. So from 0 to 3 and 9 to 12, the particle moves to the right. The reason is at the t equals 0, your v of t is positive. And also at the t equals 12, your v of t is positive, so therefore you have to include. Okay, if you look closely, your v is 0 equal 1, and your v of 12 is also equal to 1. So now let's take a look at part B. Write but do not evaluate an integral expression that gives the total distance traveled by the particle from the time t equals 0 to t equal to 6. So to find the distance, we do the a to b, 0 to 6, absolute value v of t dt. Absolute value v of t, this is a speed function. So therefore you do integral u to 6 speed times time. And you don't need to evaluate it. Of course, if they ask you to find out the answer, all you have to do is type in the calculator. Then you will get the answer. You do integral 0 to 6, and then you put the absolute value y1 dx. Then you get your answer. Now let's go to part C. Okay, part C. find the acceleration of the particle at time t. So they ask you to find the a of t. And after that, is the speed of the particle increasing, decreasing, or neither at the t equals 4? Explain your reasoning. So they ask you to find is the speed increasing, that means speed up, or slow down, or neither at the t equals 4. So you have to find both a of 4 and v of 4. If they have the same sign, it's speeding up. If they have opposite sign, slowing down. Okay, so now let's find the a of t. So v of t equal to cosine pi divided by 6 times t. And a of t equal to v prime of t. So we're going to use chain rule over here. The due to cosine is negative sine. And then we put pi over 6 times t. And immediately you find the duty of the inner, which is pi over 6. So we finished this. Now next step, you're going to find the a of 4 and v of 4. So there are two ways. There are more than 2 ways to find a of 4 and v of 4. I'm going to show you 2 ways today. So here you can do substitution. Definitely that's one way. Negative sine pi over 6 times 4 and then times pi over 6. Okay, so now we are going to use our calculator. So you get negative sine and then times 4 and then times pi divided by 6. So you just type it in. So you get negative 0.453. And that's another way. You already have your function. This one is your v of t. So now I am going to do math 8 x function 1. And you evaluate that x equal to 4. Okay, just like if you do the ddx and the y2 do y2 of 4. So that's the third way. Okay, so here you get the same answer. Even though the last few digits are not the same, because that is the problem of our device. It's not very accurate sometimes when you go more than 5 digits to the right side. But when we round it to the nearest thousandth, that would be good enough. So we had negative 0.453. Now we have to find v of 4. So one way is you type it in into the cosine pi over 6 times 4. Again, get negative 0.5. The other way is going to be, you already have your function y1, so you do y1 of 4. So you got the same answer. So either way, okay, so you use it according to your situation. So now we have a of 4 and v of 4 have the same sign. So a of 4 and v of 4 have the same sign. So the speed is increasing at t equal to 4. In other words, it speeds up at t equal to 4. It's a different vocabulary. So now we finished part C. Let's take a look at part D. Part D. The question said that find the position of the particle at t equal to 4. So now position at t equal to 4 equal to the displacement. So 0 to 4 v of t dt and plus initial position. So displacement, do integral 0 to 4 v of t dt is the displacement from 0 to 4. And then this the initial amount. So now we are going to say x of 4 equal to integral 0 to 4 v of t dt and plus negative 2. So now I'm going to use my calculator, math 9. Okay, you're going to do 0 to 4 I1 dx and plus negative 2. So I got negative 0.346. 0.346. So we finished. So x of 4 equal to negative 0.346. Now let's take a look at part E. Part E said, is the velocity increasing or decreasing at t equal to 1? Is the velocity increasing or decreasing at t equal to 8? If you want to find the velocity increasing or decreasing, you have to use the v prime of t. So you're going to use v prime of t, the slope, to determine if the slope is positive, then the v is increasing. If the slope is negative, then the v is decreasing. So we find v prime of 1. V prime of 1 is a of 1. So we already have the function v over here. So now I'm going to do is math 8. I am going to find the derivative of the function at 1. So I got negative 0.262. So because the slope at the 1 is negative, so we say that velocity is decreasing at t equal to 1. So now we're going to do the same thing and find the velocity prime. Okay, v prime of a. You got 0.453. So this one's positive. So we say that the velocity is increasing at t equal to 8. So one more time. If the v prime is negative, the velocity is decreasing. If the v prime is positive, the velocity is increasing. So we finished part E. Let's go to part F. Okay, part F. What is the meaning of the integral 0 to 3at dt in the context of problem? Find the value of this. So now we are going to see 0 to 3 integral a of t dt and see what it means. So we know that the antiderivative of this is going to be v of t. So it's going to be v of 3 minus v of 0. So this means the change in velocity, okay, from t equal to 0 to t equal to 3. So now let's see the change can become positive or negative. If the change is positive, that means increase. The velocity increase, okay? If the change is negative, that means the velocity decrease. Now we're going to calculate this. Because we don't have the function a of t, we do know b of 3 and b of 0. So we're going to use our calculator. So you got your y1 of 3 minus y1 of 0. You got negative 1. Okay, so now we say that equal to negative 1. We don't have the unit over here. It could be like unit per second, unit per minute. Okay, we don't have the time. We don't have the unit for the horizontal part. Okay, so now what does it mean? Okay, the velocity decrease 1 from t equal to 0 to t equal to 3. You cannot say this is v of 3. Some people think that automatically equal to v of 3 is not true. It depends on your initial velocity. Okay, your initial velocity is equal to 1. Cosine 0 equal to 1. So therefore, you cannot say this equal to your VA3. Your VA3 definitely is not equal to -1. Okay, I prove it to you. You can look at the graph. This is your velocity function. Your VFD3, in fact, is going to be 0. Okay. Now, let's go to part G. At what time t is the particle farthest to the left? Farthest to the left means you are going to find the absolute mean. So we need to find the absolute mean of the position function. So we use the x prime of t, which is v of t. The derivative of the position is v. So now we are going to see where the critical value will be. So v of t equal to 0 at what number? We already found it in part A, which is at t equal to 3 and t equal to 9. Okay, so now we have 0, 3, 9, and 12. Well, we already said that from 3 to 9 is negative and here is positive. So we have the symbol sketch. So we can see that x of 0 and x of 9 are relative mean. So your x of 0 equal to -2. So it was given to you. We just have to find x of 9 and see this one is going to be smaller than this. So now we have x of 9 equal to integral 0 to 9 v of t dt and plus the initial amount. Displacement plus the initial amount. So we're not going to use our calculator. So we do 0 to 9. Okay. So we get -3.9099. So definitely this one is smaller. So therefore, the answer is this one is absolute mean. So we're going to say it, okay, farthest to the left at t equal to 9. So we finished question number 2.